90% cost reduction. One question. Amazon Prime Video 2023. A team of experienced engineers built a distributed microservice architecture for audio and video monitoring. Orchestration cost dominated. Inter-service data transfer ate the budget. Then someone asked a question nobody has asked before. Do we actually need distributed service for this workload? They moved to a monolith, 90% cheaper. They never had a scaling problem. They had an assumption problem. 90%. Not a clever cache, not a 10% optimization, a 90% cost reduction by questioning one assumption. Today, I'm going to show you exactly how to ask the right questions before you build the wrong thing. And I will give you a toolkit you can use Monday morning, whether you are choosing a database, debugging production, or deciding if you actually need Kubernetes. So what is the first principles thinking in software? Not the Elon Musk version, not the philosophy lecture. The version you use when staring at a system design doc on Monday morning. But first, let me show you why getting this wrong cost real teams, real money. 42% of microservice adopters have already consolidated back. That number is coming in a moment. This is the core distinction. Left side, reason by analogy. What does Netflix use? Copy it. Everyone is doing microservices. We should do too. On right side, reasoning from the first principle. What are my actual access patterns? What is my team size? What are my real failure modes? Design for this system, right? Both have their place, but if you default to analogy without checking, you end up like that Prime Video team. Here is what it looks like in practice. Choosing a database from first principles. Instead of everyone uses Postgres or MongoDB is web scale. You ask 5 questions. 1. What are my actual read and write patterns? Second, what consistency guarantees does my business logic require? Third, what is my data shape? Relational, document, graph, time series, etc. Fourth, what can my team actually manage operationally? 5. Now pick the tool, the one that fits, not the one everyone talks about. Sometimes Postgres is the right call, but you choose it for reasons, not vibes. Quick cross-domain insight. Elon Musk asked, what is a rocket made of? Found the raw materials cost 2% of the final price. The other 98% was assumptions. In software, same question. How much of your infrastructure complexity is actually serving user needs? And how much is serving assumptions nobody has examined since the original architecture doc? That question alone is worth the entire episode. Here is why this is hard even for experienced engineers. Researchers found that experts categorize problems by underlying principles. Novices categorize by surface features. In software, are you thinking this is a caching problem? This is surface. Or this is a read heavy workload with tolerance for staleness? This is the principle. Senior engineers do not just know more patterns, they organize knowledge around why things work. And that distinction, surface versus principle, is everything. Okay, so you understand the concept, but understanding is not enough. Let me show you what happens at industry scale when teams copy patterns without questioning them. Real companies, real money, real outages. And here is the thing. The numbers are worse than you think. 42% of companies that adopted microservices have consolidated back. 60% says Kubernetes complexity outweighs benefits for their workload. And a peer-reviewed study found 60% of hiring decisions are driven by tech trends, not fitness for the problem. This creates a feedback loop. Engineers adopt trendy tech to get hired, regardless of whether it solves their actual problem. Resume driven development. It is empirically validated. Now, here is a counter example. The team that got it right, Shopify. So, over 1,000 developers, one of the largest Rails code bases in the world. They could have gone microservices, they had the scale. Instead, they asked one question: what problem are we actually solving? The answer was coupling between domains, not deployment independence. So they built strict boundaries inside a monolith. Black Friday, 30 terabytes per minute, no distributed systems overhead. The wrong architecture, but chosen for the right reasons. Before I continue, I want you to think about this. Your current system, your current stack. Is there a decision that was made before you joined that everyone treats as settled, that nobody has re examined? Maybe it is the message queue, maybe it is the service boundaries. What would happen if you asked why? Hold that thought because I'm about to show you what happens when you do question it. $10 million saved. DHH and 37 signals asked one question: is renting computers actually a good deal for our specific workload? On the left side, $3.2 million a year on AWS. Predictable workloads, stable traffic, renting because everyone should be in the cloud. Nobody did the math. Right side, they did the math. 600,000 in hardware. Database queries 3 to 5 times faster. 5-year savings over $10 million. Sometimes the obvious choice is obviously wrong. June 19, 2024, our template defined 21 input parameters. The code supplied 20. Nobody asked what happens if these do not match. 8.5 million Windows system crashed. The fix was trivial once found, but finding it required asking one question: what must be true for this template to execute correctly? That question, what must be true, is the powerful debugging tool I know. I will give you the full framework for it in few minutes. First principles debugging in action. October 2025, AWS Dynamo outage, 14 hours, millions affected. Everyone assumed database failure. But the first principle question: what must be true for services to reach DynamoDB? That points you straight to DNS. The database was fine, the routing was fine, DNS resolution was broken. Reasoning about invariants find the answer faster than guessing at the symptoms. One cross-domain example, because the pattern is identical, right? So Boeing adapted software from a tanker to a passenger jet without re-examining assumptions, single sensor, unrealistic pilot response times. 346 people died. Same failure mode as copying Netflix architecture without Netflix problems. The stakes are different. The cognitive error is same. Now you have seen the cargo cult, companies copying patterns, outages from unquestioned assumptions. But here is why this matters more in 2026 than ever before. We now have tools that generate plausible wrong answers at scale. 43% of AI generated code fails in production, even after passing QA. Let me show you why. 43%. Almost half of AI generated code changes require manual debugging in production. After passing QA, after passing staging. The code looks right, the test pass, but it fails because the AI generated the test data too. A closed loop. Both the code and its verification share the same blind spots. Two-thirds of developers report the same frustration. AI code that is almost right, handles the common case, compiles, passes the obvious test, but misses the edge cases that require understanding the system's actual invariants. This is pattern matching without principles. It looks right until it does not. Let me make this concrete. A senior engineer, not a junior, shipped AI generated authentication code, passed every test, passed code review. 2 weeks later, production outage. The AI learned from outdated Stack Overflow answers, implemented a deprecated overflow. The first principles question that would have caught it: does this match the current specification? Nobody asked. The ghost code problem. One team generated 40% of their code base with AI in 2024. 2 years later, logic nobody can explain. The AI generated code and test data both share the same blind spots. The only difference is first principle verification. What invariants must this code maintain? Not just do the test pass. This is the formula. Trained human plus AI beats AI alone. AI alone beats untrained human alone. The keyword is trained. Trained in reasoning about what the code should do, in checking invariants. That is your mode. AI made pattern matching cheap. Your value is reasoning about what is correct. Now, let me give you the exact tools to do this. You understand the problem, the cargo cults, the outages, the AI traps. Now, what do you actually do differently? I have 5 tools for you. Each one takes less than 2 minutes to apply, and the first one alone would have saved Amazon Prime Video 3 months. Tool number one, the decision flow. Before choosing any tool, any architecture, any framework, run through this. What problem am I actually solving? If you cannot answer clearly, you are not ready to pick a solution. Is this my problem or one I copied from a conference talk? If copied, does the original context match yours? If not, design from your actual constraints. Be honest. Your last big technical decision. Did you start with the solution? Let us use Kafka, let us use Redis. Or did you start with the problem? Most of us start with solutions. It is natural, but it is backwards. The tool should be the last thing you choose, not the first. Okay, tool number two. This one is for debugging. Tool two, the invariant debugging loop. Instead of guessing at symptoms, maybe it is the database, maybe it is the network, you ask one question. What must be true for this system to work? Then you check each invariant until you find the violated one. That is how the AWS team found the DNS issue. That is how CrowdStrike's parameters mismatch was found. Simple, devastating, but works every time. Tool 3, 5 whys apply to a real production incident. So the API is slow. Why? Connection pool exhausted. Why? Query is taking 3 to 5 seconds. Why? Missing index on user events created at. Why was it not caught? No query plan review in the PR process. Why no query plan review? Because nobody asked what happens to this query at a scale. The root cause is not the missing index, it is the missing question. Right? So here is tool 4. Back of envelope myth before architecture. So what is back of envelope myth? Do we need a message queue? Do not start with Kafka is industry standard. Right? Start with this. How many events per second? What is the processing time? Can the consumer keep up synchronously? If yes, you do not need a queue. You need a function call. Save yourself 6 months of operational complexity. Tool number 5, career context. This skill compounds at every level. When you are junior, ask about access patterns, not popularity. When you are mid-level, push back in design reviews. What problem does this actually solve for us? when you are senior. Prevent cargo cult adoption at org level. Show me the math, right? The earlier you build this muscle, the more it pays off. But here is the thing, there is a danger to all of this, and I need to tell you about it before you leave. Quick self check before we move on. So, when you make a technical decision, are you categorizing the problem by what it looks like or by what principle governs it? So, left column, surface features, it is a caching problem. We need microservices. Right column, deep principles. Read heavy workload with tolerances for staleness. Independent deployment of components with different change rates. If you catch yourself on the left, pause, reframe. What is the actual underlying constraint? Now, I promised you I would be honest. A mentor who only tells you the upside is not a mentor. They are a salesperson, right? So, first principle thinking is not always the right move. And if you over apply it, you will ship nothing. So, let me show you when your patterns are actually more valuable than reasoning from scratch. Gary Klein spent decades studying experts under pressure, firefighters, military commanders, surgeons. His finding, for familiar problems, your trained intuition is faster and more accurate than reasoning from scratch. 80% of the time. If you have deployed 50 Rails apps, trust your gut on Rails architecture. The danger is not pattern matching, it is pattern matching in unfamiliar territory while feeling familiar. Here is the complete picture. Left side. Use first principles when the problem is genuinely novel, when the decision is irreversible, when the context does not match the pattern solution, when AI generated it and you cannot explain why it works. Right side. Trust your patterns when you have high experience in this exact domain. When feedback loops are fast, when time pressure is real and the decision is irreversible. Sorry, when the decision is reversible. The meta skill is not always think from first principles. It is knowing which column you are in right now. The key signal, reversibility. Roll it back Monday, trust your gut. One way door, reason from the first principles. Let me close with three principles. If you remember nothing else from this episode, remember these. One, the question that prevents cargo cult engineering is, what problem am I actually solving? Ask it before every architecture decision. The answer might surprise you. So the question is, what problem am I actually solving? Second, your moat against AI is reasoning about correctness from invariants, not writing code. Reasoning about what the code should do. Three, match your thinking mode to the stakes. First principles for one-way doors, pattern matching for two-way doors. Know which door you are walking through. Feynman wrote this about the Challenger disaster. For a successful technology, reality must take precedence over public relations. For nature cannot be fooled. Your software does not care about your assumptions. It does not care what architecture Netflix uses. It cares about physics, latency, throughput, memory, network partitions. Nature cannot be fooled, neither can production. So that is what we covered. First principles for software grounded in real production stories, the cargo cult disasters, the AI traps, five concrete tools, and the honest nuance. The real skill is knowing when to reason from scratch versus when to trust your experience. If this was useful, subscribe. I make these because I have learned all this hard way and I want to pass on this knowledge or information, whatever the little experience I have. So the topic next time will be the mental models, how to build accurate maps of the systems you work on. Because first principles thinking requires an accurate model of reality, and most engineers have a wrong one, right? So see you then.